Good morning, one and all. Welcome to another session on data mining. In this session, we are going to start with Unit 2. Unit 2, when you look into the syllabus, I told you that Unit 1 deals with an introduction to data mining and different aspects of data mining. And a lot of pre-processing methods are covered in Unit 1. Unit 2 is about association rules. It is one form of or one approach in data mining. Unit 3 is on classification. Unit 4 on clustering. These three are the major data mining methods or approaches. So we will look into some algorithms for each of these approaches. And in Unit 4, we will look into how these algorithms are applied in real world examples. So we will look into that in Unit 5. When you concentrate on Unit 2 deals with one specific approach of data mining called as association rules. Here we will try to define where exactly these association rules are used, what is the requirement, and when exactly is association rule applicable, and what are the methods that run behind it. This is what we are going to see in Unit 2. When we consider this, this is actually part from your textbook. This is included in chapter 5. We will cover the basic concepts first. Then we will see what is frequent item set mining. And then we will see how to evaluate the patterns that are mined. This association rule is applicable to industry-based. So when I try to gain some business intelligence, I can use this kind of data mining. When I say that, you can always see uncertainty is a part. It is a very, very important part in our daily life and also in business. Now with the COVID situation prevailing everywhere, we can see that uncertainty has crept inside our mindset already. Nobody is certain of what will happen tomorrow. No business is certain of their progress tomorrow. So, there is always an uncertainty involved, and whenever there is uncertainty, we see that there is a lot of interest towards that. Or I can say there is a lot of anxiety in that. People are very anxious, people are stressed because they are uncertain. And when they look at businesses are not doing so good these days because there are a lot of factors involved in business and people are not able to meet out those factors because of the conditions that prevail now. Was it anyway possible for us to know whether we will progress or not? Now every organization has to take a decision on whether to invest for the future or cut costs down. So we are still not certain about what decision to make. Some of these examples you can see, other than the COVID situation, you can see you have got two stocks. You are not certain of which will deliver better growth in the coming year. There is some uncertainty there. And then you have an advertisement campaign and you are not sure or certain which of them will give, whether it will be successful or not. So for every business decision that we take, we always have a level of uncertainty involved, which indicates whether we will progress or not. With this level of is it possible to assess uncertainty? What in general is uncertainty? Uncertainty is the chance of something either happening or not happening. Can I somehow measure this level of uncertainty? Have we done this already? I hope all of you would have done this at some point of time. Now, I'll give you an example. Imagine you are throwing a dice or you are playing a card game. There is always uncertainty involved. We do not know what the outcome will be. The same with investing on a business platform. Now, I want to invest on a business platform and I am not certain of what the outcome would be. I am not able to assess. There are a lot of chances. But still, when we played with a die or when we played with the cards, were we able to assess that level of uncertainty? How did we assess the level of uncertainty? Did we use any mathematical model to help us understand that uncertainty? Yes, very good. It is using probability. Probability is a measure of how uncertain things are or how certain they are about to happen. So, this probability is a tool that we can use in every area of uncertainty. Just like in COVID times, what we do is we look back into the past statistics and say, yesterday there are 500 cases. The probability of having 500 cases today is 95. So, if 95 percentage, surely I'll have around 500 cases reported today also. So, that level of certainty I am able to attach to the randomness in events. Will this somehow help in my business decision making? So, I know I'm going to invest 1 crore rupees on something. Can I assess the probability of that particular project and say, with 90 percentage of chances, it will fetch an outcome of say 2 crores in 2 years time? So, this is very, very essential when you look at the business perspective of probability. But plain measures of probability cannot help us, or it takes extensive expertise and domain knowledge to find out the probability of some of the events because it is not dependent on one factor. There are multiple factors affecting the environment. So, it is difficult to calculate or model that probability mathematically. So, can we devise certain methods that can help us get that probability a bit more easier? So, that is our idea for discussion today. So, we have a probability value which has to be recorded, and this probability is a measure of how I am going to take my decisions, and with that I have to quantify my level of uncertainty. When I try to quantify this level of uncertainty, I can find out and judge whether I can do it well or not. Now, probability is used in a lot of ways. If you can see, it was so interesting for me that gamblers were the first people to take an interest in probability. People who were doing gambling on cards, this polo and whatnot. I'm not sure what that game is called as. Where they, all these gamblers, I'm not sure what that game is called as. So that those type of gambling activity, people who were involved in that, they started using probability first. They wanted to know how certain they are in winning their next lot. So they started calculating their chances of getting a win or chances of getting a loss. So when they started calculating that, other people started formalizing that calculation, and they brought into account for probability, and they started involving multiple factors, and multi-factor probability calculations came into picture. Once gamblers started, they also then followed the insurance company. What they did was they were collecting money, and based on the probability of them having to pay back something, they actually started investing on insurance. So they took into the likelihood of a person getting killed or claiming that insurance amount. So these are areas or venues where probability was used. Now we see it is very, very essential not only for business but also for social things. Now, COVID times, we have what is the probability of survival, what is the probability of a person getting infected, what is the probability of. Now we see that has become a common thing these days. So people have got used to statistics. Everybody is saying out of these many cases, these many are from Hyderabad. So statistics has become so very applicable to us these days. This is a classical approach. So when I say probability, it always runs on a scale. The probability runs from impossible events. What is an impossible event? Can you give me an example of an impossible event? No one in Hyderabad gets affected with COVID today. Perfectly impossible, because one or the other person is going to get infected. So getting 0 cases today is impossible. So on another level, on the other end of the scale, I have a completely certain event. It is for sure it will happen. Okay, an example of that. Someone getting infected with COVID today. Someone or the other. Somebody will definitely get infected. So someone getting infected today is a certain event. So so if you look into the scale, you can see that it varies from impossible to completely certain. And there are certain unlikely events, not very much possible, but there are chances, but very remote chances. Such events are called as unlikely events. And when the chances are high, if the probability is a little higher, then you have like these, you can call them as likely events. And when you have exactly the chance of both happening and not happening equal, then it is called as an even chance event. Now, people who are in Hyderabad getting infected with COVID, I can't say it is even chance, it's an likely event. So it's the level of probability that we have associated with it. So the probability of tossing a coin and having it land on heads is 1/2. So it has even chance. The probability of picking a red card from a standard pack of cards is 1/2, even chance. So such is called as the probability. Now when I have probability in place, I am going to find out, based on the occurrence of one event, how much probability is going to change. Now, a person getting infected with COVID, I say it is very likely. But Does it change because of any other event? The person completely stays at home or the person goes outside. There are two different options. Now, in that scenario, does my probability change? Of course, it changes. For a person who is completely at home, the probability of getting infection is very less. Whereas, for a person who goes outside, the probability is going to be high. Now, can we, for any measure, see whether the probability changes because of something? That is called as relative frequency. Based on one activity, does the probability of another change? That's called as relative. Now the relative frequency, I say, it is there's a law named as law of large numbers. The law states that over a large number of trials, the relative frequency with which an event occurs will approach the probability of occurrence for a single trial. Which means, now if I throw a dice, what is the probability of having the number 1 on the dice? It is 1 by 6. Imagine I throw the dice 10 times and I am getting only one. I am getting the value 1 on the die only once. So I have got only 1 out of 10 times. But my actual theoretical probability value is 1 by 6. 1 by 6 is far higher than 1 by 10. So in practice, whatever I get is actually a relative value from the theoretical value. So if I try for a very large number of trials, then the actual frequency or the actual probability will approach the theoretical probability. So imagine if I have, instead of throwing the dice 10 times, if I throw it some 1000 times, then I can see that it has approached the theoretical probability of 1 by 6. So this is how we the law of large number defines probability. So probability is the proportion of times an event is observed to occur in very large number of trials. An example is you toss a coin one time. The relative frequency for heads will be either 0 or 1. If we toss it great many times, however, the relative frequency will approach 0.5. That is theoretically whatever it is supposed to be. So out of 10,000 coins, I get 57,976 heads and the rest are tails. So the approximately it comes to the theoretical probability 1 by 2. Insurance industries use these relative frequencies. So they use it for charging the premiums or to take a decision on whether to accept the application or not. These are based on relative probability values. Now, Unit 2 actually deals with frequent pattern analysis. Now, what is a frequent pattern? Why are we concerned about frequent patterns? How is data mining related to frequent pattern? What is the relationship between probability and a frequent pattern? A frequent pattern is a pattern or a set of items or subsequences that occur frequently in a database. So, occurrence of head is having a frequency of 1 by 2 or 50% of the time I am going to receive heads. This is one event. You take multiple events. I am throwing 2 dice at a time. how much probability do I have to get 1 on both the dice? So that is a pattern. So the number on the first die and the number on the second die form a pattern. So how much frequently do I get the pattern 1 1? So if I start analyzing this, it is not only applicable to these problems, I can also say for an insurance company, for a person with a value of sugar this much, pay scale of this much, and age of this much, what is the probability that he gets a claim? So that is a pattern. If I look into the probability of occurrence of such patterns, it helps me get deeper insights about the claims that are made. So having that in mind, we are going to start understanding our data in the form of patterns, each having their own probability of occurrence. So patterns that keep repeating itself frequently are called as frequent patterns. Now, where exactly are we going to make use of these frequent patterns? What is the use of making this pattern analysis? I'll tell you a problem domain. It's called as a market basket analysis. It analyzes the customer's buying habits for finding associations between different items that the customers place in their shopping baskets. So you try to identify which are the items that are frequently purchased together. So every time a cart is placed, you analyze the items in the cart and then find out what are the frequently purchased items. So when you get that idea, you get a pattern that repeats itself frequently for multiple customers. So this is one example where frequent pattern analysis is used. And you can also have a loan application process. You can have a network security. You can find out how much is the how much insecure this network is, or how many patterns of hacking has occurred in the over the network. All of these are frequent pattern analysis problems. So you try to find out how much is the frequency of occurrence of various patterns. Now, this pattern analysis is done using calculation of frequency. So I am going to calculate the frequency of various events and see which of them have higher probability of occurrence. So if they have higher probability of occurrence, then it is very natural that they may repeat in the future also. So such patterns we are interested for predicting what would happen in our business tomorrow. So the motivation why people started doing this is there is always an inherent regularity in data, even though we say that it is uncertain, even though we say everything is uncertain, we always have certain level of regularity in the data, that we can make use of that regularity to find out what products are purchased together, what are the subsequent purchases after buying a PC, what kinds of DNA are sensitive to this new drug, can we automatically classify web documents, etc. etc. So you make use of that inherent regularity in data, and then you find out how it can help you grow your business. Now these are many applications in which frequent pattern analysis is used. Basket data analysis, cross marketing. When you design a catalog, when people design a catalog, they usually find out what are the items that are purchased together frequently, and they put them in the together or close by in the catalog, so that the moment I want to buy something, I naturally go in for buying the other one also. So that is used in catalog design, and you also can come up with business strategy and campaigns that hold relatively frequently bought patterns together. So these are some applications in which frequent patterns are analyzed. Okay, the same thing. Okay. Now this is how a frequent pattern looks like. A pattern is represented in the form of a predecessor and a successor, or a predecessor and a consequent. You can read it as people who buy computer buy antivirus software with a support of 2% and a confidence of 60%. This is what the rule says, or this is how a frequent pattern is represented. Now, the computer is called as the predecessor and the antivirus is called as the consequent. So, one event happens first, followed by the occurrence of another event. We always have some mathematical, we measure quantitatively how frequent the pattern is using two measures. The first measure is called as support and the second measure is called as confidence. Support tells me out of the entire set of build elements, how many people bought the computer. Okay, how many were bought the computer and the antivirus. Say for example, if you have 100 people buying something in your store today, and if your support is 2, it means that 2 people out of 100 people have bought computer and antivirus together. Okay, and there is a level of confidence which is attached to it. The confidence means that 60% of the time, if every time a computer was bought, out of that 60% of the time an antivirus was also bought. So it defines how relatively the antivirus is bought every time a computer is bought. That is called as the confidence of the pattern. So we are going to use these two measures to analyze our products or our market basket and see how we can generate frequent patterns. We are going to look into two different algorithms that can mine these frequent patterns from a given set of data. So this unit is going to be mathematical in nature. We are going to calculate some probability values. We are going to look into these two algorithms. And in the previous examinations, when everything was offline, every year we used to have one question, which is a worked out, they'll ask only a mathematical question, a problem to be solved in Unit 2. We hope that in this coming year also, you will have an offline examination where you can solve this mathematically. So we will, in this unit, this is just an introduction to the unit, we will see two algorithms that can help us mine these sort of patterns from the database. Now imagine this is the set of items purchased on a store. So I run a store in which these are the items billed. The first column represents the transaction ID, and if for every transaction ID, they have listed the items that are bought in that transaction ID. Now if you look here, now if you look here, you see that the yellow color represents the customer who buy bread and the blue color represents the customers who buy diapers and the green one represents the list of customers who buy both. So this is the basic measure we are going to use in both of these algorithms, and we are going to calculate for every combination of items that are purchased, what is the level of probability that they are purchased together. That is how we are going to calculate and find frequent patterns in the database. So with this introduction, I would like to stop for today's session. We will look into an algorithm for generating these frequent patterns or analyzing frequent patterns or deriving frequent patterns from the given database. So we will take some mathematical examples and try to work them out in the next session. For this session, I would like to conclude here. Thank you one and all. I hope all of you will stay home and stay safe. Looking forward to seeing you all physically in the college very soon. Thank you one and all.